Okay, so we're ready to start 1.4 compound interest, looking at present value. So what we're doing in this section is trying to determine the principal or the present value of an investment given the future value and compound interest. So present value is the amount of money that must be invested now to result in a specific future value at a certain interest rate in a certain given time. So it says in 5 years, after graduating from college, Cal wants to spend a year traveling in Canada's 3 territories. He plans to start in Yukon and then travel to Northwest Territories and Nunavut. Cal has determined that he will need at least $15,000 for his trip. To reach his goal, he wants to invest money now. He has chosen a GIC at 7% compounded annually. How much does Cal need to invest now so that he will have $1,500 in 5 years? So, to do the work for this, if we think about our formula that we have for compound interest, A is equal to P times 1 plus I to the power of N, where P is your initial investment, A is your future value of it, I is your interest rate, and N is the number of years that you're doing this, or number of compounds that you're doing it. And remember, for interest rate, if it's anything but annual, you have to divide through by the number of periods for that. So for this, we know he wants to end up with $15,000. We're trying to find out how much he started with. We know his interest rate was 7%. And the number of years he has to do this is 5 years. So using our formula, we would have 15,000 is equal to, we don't know the principal, but we have 1 plus 0.07 to the power of 5. So what we could do then is divide out by this, 1.07 to the power of 5, 1.07 to the power of 5. So these two will cancel, and you're left with $10,694.79 as your principal. Now, if you wanted to do this on your calculators, your N for this would be 5, because that's the number of, that should be an N, not a 10, your number of payments or periods that you have. Interest is 7. We don't know the present value. Our future value was that 15,000. Payments per year and compounds per year will both be 1. So on your graphing calculator, remember you have to go into apps. We want finance, TVM solver. So here we start. So 5, interest rate is 7, present value, we don't care, payment, or sorry, present value, we're trying to find payment, we just stay at 0. Future value, we want it to be 15,000. 1 and 1, go back up, alpha, enter, 10,069 or $10,694.79 was our answer. Okay. Determine the present value investments earning compound interest. So that was just a simple interest one where we didn't, it was it wasn't a simple interest one, it was an easy interest one because we didn't have to do any compounding of interest. So in this one, Ginny is 18 years old. She has inherited some money from a relative. She wants to invest the money so that she can buy a home in Milk River, Alberta when she turns 30. She estimates that she will need about $170,000 to buy a home. Obviously, housing prices in Milk River are fairly cheap. How much does she have to invest at 6.5% compounded annually? What is the ratio of future value to present value? And then how would the ratio change if the interest rate decreased to 6% but was compounded semi-annually? So, for our first one, so her future value, she wants $170,000. Her principal, don't know where that's, we're trying to find out. Her interest rate is 0.065. And N is the number of years she's going to be doing this for, so 30 to 18 is 12 years. So if you think about what we did in the last question there, you need to figure out what your P is, right? That's what we're trying to do. So if we look at our formula, area is equal to P times 1 plus I to the power of N. If we want to find out P here, we're going to divide by 1 plus I to the power of N. So that means that our formula is really P is equal to A over 1 plus interest, or I, to the power of N. So if we substitute in here, we have $170,000 over 1 plus 0.065 to the power of 12. So when you do that math on your calculator, you get $79,846.09. Now, of course, you could do this on the graphing calculator. This would be your future value. This is what you're trying to find, and your interest in your N. And because it's compounded annually, your CY and your PY would equal 1. So B says, what is the ratio of the future value to present value for Ginny's investment? So it's future value over present. So 170,000, that shouldn't be a decimal, pretend it's not there, over 79,846.09. It's 2.14 to 1 is your ratio. Okay, C then asked, what would happen to her, how would the ratio change if the interest decreased to 6% but was compounded annually? I'm just going to do this on the next page here. So for A over P is what we were looking at that other one. Actually, whoops, I'm just going to fix that. If my A, future value, is equal to P times 1 plus I to the power of N, what I want to do is I want to find out what is happening to this ratio. So if I divide through by those, I have A over P is equal to 1 plus I to the power of N. So by substituting 1 plus I to the power of N, this is going to be 1 plus 0.06 to the power of N, though now instead of being 12, because it's compounded semi-annually, is going to be 24. So that equals 2.03. Oh, and I goofed up right here. Remember, as soon as you're compounded anything but annually, you have to divide your interest by your number of payments. So that should be 0.03 because it would be 0.06 compounded annually, so that's twice. So her ratio, instead of being a 2.14 to 1, will be 2.03 to 1. So it's going to drop down a bit. So Agnes and Bill are musicians. They have researched the costs to set up a small recording studio. They estimate that $40,000 will pay for the soundproofing, recording equipment, and hardware and software that they need. They plan to set up the studio in 3 years and have invested 9.6 compounded quarterly to save for it. How much do they need to invest? So for A, our A is equal to 40,000. Our P, that's what our present value, we don't know. Our interest rate was 0.096, and our N is, we have 3 years that they're doing this times quarterly, so 4 years, so that equals 12. So using the formula, P is equal to A times 1 plus I over N. So this is equal to 40,000 divided by 1 plus our interest rate. So 0.096 divided by 4 is equal to 0.024. To the power of 12. So that equals 30,000. Oh, I don't know why I keep wanting to put a decimal in. $30,092.66 is what they would need to invest right now. So if you did this one on your calculator, move up, there we go. So our N is equal to, now I'm going to show you 2 ways of doing this. If you do this for this where N is equal to 12, so like I've set it up here, then when you do your interest rate is 9, I'm just going to clear this. Oh, come on. It won't move down for me. Enter. There we go. That's a 0. This one was 40,000. If I do my N at the top of that one as 12, where I've multiplied the number of years times the number of periods, then I have to change this to a 4, because the payments per year would be 4, and your compounds per year is 4. And then when I go back up to present value, it'll give me that. Oh, it changed it a little, probably because of my decimal being off. I rounded here, so that's I rounded on that 0.024. So let's try it. If you leave this as N is equal to 3, oops, change this to 0, put that, compounds per year is 4, put this one as 1, I believe. Oh, no, that does it automatically. Let's see what it does. Get up there. Nope. Can't remember why it didn't change it. So for right now, we'll leave it at the 12 and 12, and I'll have to figure that out for you. Okay, so back to here. How much interest will they earn over the term of their investment? So your interest then is just your future minus your present value. So this was 40,000 minus your 30,000 and 92.66. So they would have earned $9,907.34. Okay, sorry. I just wanted to go back and see what I had done wrong here. So my PY, I needed to clear it because it left it at 4. So your PY needs to be 1. If you are leaving your number of payments, your N, as just the number of years you're doing it, then your compounds per year is whatever that is. If it's semi, it's 2. If it's quarterly, it's 4, and so on. But then your P per Y needs to be 1. If you put your N as the total number of pay periods that you're going to have, so in this case we had 3 years and 4 pay periods, then I would change that to 12, change my PY to 4 and my CY to 4. So you can do it either way and you'll get the right answer. If you're only doing it as N is the number of years that it's happening, then your P per Y needs to be 1 and your C per Y, your compounds, needs to change to however many are in that period. Okay. So example 3. It says determine, just got to flip my page here. Oh, I don't want that on there. Determine unknown interest. So you're finding the interest when you're giving your other information. So Laura has invested $15,500 in a RESP. She wants it to grow to $50,000 by the time her newborn enters university in 18 years. So what interest rate compounded annually will result in a future value of $50,000, and round your answer to 2 decimal places. Okay, so if we're looking at this, she is starting with $15,500. She wants the future value of it to be $50,000. Her interest rate, we don't know. Number of years is 18, and it's being compounded annually, so it's just 18. So if we use our formula, A is equal to P times 1 plus I to the power of N. What we're trying to find is this. Trying to find this part here. So that means let's divide through by P. So A over P is equal to 1 plus I to the power of N. So I have 50,000 over 15,500 is equal to 1 plus, and my interest we don't know, but we know it's to 18. So to solve for this, we're going to need to 18 root this side, 18 root that side. So that's going to cancel. And if you did 50,000 divided by 15,500, and then do your, on the graphing calculators, it's the, where is the button on here? Where's the X to Y button? How come I can't see it? Anybody? You have to go into the math. Here, I'll do it on here for you. So if you go into math, I want this. I want number 5. But I think I had to do it first. Let's see. Oops, yeah. Okay. We're going to quit this. Okay, so it's 18. Then my math. I want number 5. I want the whatever root. So in brackets, I put 50, 1, 2, 3, divided by 15,500, bracket, the 1.0672. So I haven't rounded it yet. I'm just going to leave it like that for right now, is equal to 1 plus I, because this and this will cancel. So that means I'm going to subtract 1. So 0.0672 is equal to I, so the interest rate, if I round to 2 decimal places, will be 6.72%. Okay, B says, suppose that Laura wants her 15,500 to grow to at least 60,000 at the interest rate from part A. How long will that take? So what we want to find in this case is our N, right? Our A is going to be, what did she want it to be? 60,000 instead of 50. Our present value is going to be our, whoops, 15,500. Our interest rate we know is 6.72. We want to know what N is. So if you do this on the calculator, so our N is what we're trying to find, so let's leave that as 0. Our interest rate was 6.72. Present value was, remember when you're putting the amount you're putting into an investment, it's a negative 15,500. We want $60,000. And this is still annual, so these both stay at 1. Go back up to N, alpha, enter. So it's 20.81. 20.81, so about 21 years is needed to get that $60,000. So just a little recap here. Present value of an investment that earns compound interest can be determined by the formula P is equal to A divided by 1 plus IN. So all it is a manipulation of your formula. A is equal to P times 1 plus IN. And you can then manipulate that to find A, you can use it to find P, you can use it to find I or N, depending on how you set it up. So down here is where they show that. So to find future value, A is equal to, whoops, move my arrow. A is equal to, no, it won't. Okay. This is just making me mad. Okay. A is equal to P times 1 plus IN. If you want principal, then all I've done is I have divided out by that 1 plus I to the power of N. If I want to find the interest or the N, then it's A over P. To compare investments, we use that A over P is equal to 1 plus IN. And then it's just saying that you can use your calculators to solve these as well. So there's your questions to practice.